Okay, so we have another lesson for today. So we are in Module 4, Lesson 3, the alternative definition of derivative. So last time we discussed about the uh, how to get the derivative through the limit of x as x approaches to x sub 0, then f of x minus f of x sub 0 over x minus x sub 0. Now we have here the another definition by using the h. Okay, so here we have here in which f of x plus h is a composition of two functions. Therefore, it is determined by replacing all x in definition of f by x plus h. So we have here an example. So find f of 1 of the function f of x equals to 3 minus 14x. As you can see here, x in f of x and f of x plus h is substituted by 1 since we are looking for the derivative of the function as x is equals to 1. So here f of 1 in the definition of f of x. So here we have here our function, then we change the x into 1 here. So we can see here the number 1, and then also the x here is replaced by number 1, and then the answer is negative 11. So we already have the here we have here the f of x. Next is we have here the f of x plus h. So you will just replace the x to x plus h, just like this one here, and then we replace the x into 1 here, and then we simplify it. Then the answer of f1 plus h is equals to negative 11 minus 14h. So this is our f of x plus h. Okay, so now we will minus it, no? So f of x plus h minus f of x over h as h approaches to 0. So this is constant here, or I mean it will not change as h always is approaching to 0. Okay, so here we have here limit of h approaches to 0 of negative 11 minus 14h. So this is our f of x plus h, and minus negative 11, which is our f of x, and then we simplify it, no? So 11 plus 11, 0, so negative 14 h, and h is remaining, and then we can cancel it because it is division. So the remaining is the limit of negative 14 as h approaches to 0. So we all know that the limit of a constant is the constant itself. So the answer of the derivative of the function as x equals to 1 is equals to negative 14. So we're gonna try this using the example here, 2x, this one, 2x plus 4 and f of 1. Okay, so we have here, we'll try this one over here. Okay, so our f of x is 2x squared plus 4. Let's check if it is correct. 2x squared plus 4, 2x squared plus 4. Okay, as find derivative of 1. Okay, so first we want to have the f of 1 and also the f of 1 plus h. So we are using 1 because our given is 1. Okay, so here we will have here 2 times 1 square plus 4, which is equals to 1 times 1, 1 times 2, 2, 2 plus 4, which is equals to 6. In here we have here 2 times 1 plus h square plus 4, 4. Okay, so this is our, we can simplify this, equals to 2, so we factor this out, 1 plus, so we have here this one, we have to factor it, I mean we have to multiply, we have to square it, so 1 plus 1, 1 plus 1 h plus h plus h square. Okay, so we have here 1 plus 2h plus h square. Okay, so we have here 2 times 1 plus 2h plus h square plus 4. And then we can still simplify it by you distribute that number 2. So 2 plus 4h plus 2h square plus 4. So we have here like terms, the 2 and the 4, all both constant with no variable. So we first here 2h square plus 4h plus 6. So this is our f1 plus h. Okay, to have the derivative of the function is we have to minus f of we have to limit the function of x plus h minus f of x over h as h approaches to 0. Is this correct? Yes. No? Okay, the same. Okay, so we have here our f of x plus 1, which is the, we have to put limit here first. Okay, f of x plus 1, so this one here, which is equals to this one. So 2h square plus 4h plus 6 minus our f of x, which is this one here, which is equals to 6 over h, and then it's equals to limit of h as h approaches to 0. So we have here 2h square plus 4h, then plus 6 minus 6 is 0, so we have that one. Then we can get rid of the h, no? So we have here common h, we have h here and also here, and also at the and down below. So we have here h, 2h plus 4 over h, so we can cancel the h, so the remaining is limit of h say suppose this is 0, 2h plus 4. Okay, so now, which is 1. Okay, so now we have still h remaining here, this one. So what we're gonna do, we're gonna replace it with, yes, 0. So because it is the limit of as h approaches to 0. So now we have 2 times 0 plus 4. So the derivative of the function as x is equals to 1 is 4. So 4 is our answer. Let's try it. Let's look for the answer here. So this is 2x squared plus 4 here, what? And then the answer is also 4. So it only means that using this formula is also the same answer will be derived by this formula. Okay, so that's it for the day. Thank you.